Hello everyone, this is Siddharth and currently I am pursuing my masters in construction engineering and management from Cept University. Today I am going to take you all through my third semester studio project which is the iconic curve project. This project focuses on the integrated construction practices using a beam model and looks to integrate the lean tools with the beam model. So let's start with the project brief. Iconic Curve is a greenfield commercial real estate project having plot area of 4316 square meter and built up area of 52,637.76 meter. It consists of 441 offices and 12 shops. It is located in Gift City, Gandhinagar, and it is a unconventional project having complex design and uh, the interesting thing about this project is the columns tilt by 1 degree on every floor it it consists of 38 degree of total rotation of the building. The project will be executed on the square feet contract, and for our studio thus we have fixed the scope of work of basement 1 and ground floor. The poor bifurcation of basement 1 and ground floor are mentioned here. So coming on to the quantity takeoff, once we obtained a clash-free LOD from 400 model, we automated quantities from that model for structural works, architectural works, and all the four services mechanical, electrical, plumbing, and firefighting. After getting quantities from Revit, we manually calculated quantities for structural, architectural, and MEPF works. The, the comparison of manually calculated quantities and Revit quantities are for architectural and electrical works are mentioned in the graph, and you can see that there is a variance of 5% in the block works majorly because of the uneven beam depths, and in the electrical quantities you can show that you can see that there is a variance of 2% and 3% for the cable trays majorly because of the curved electrical cable trays and coming onto the structural quantities. So the graph shows the concrete column concrete quantities for core wall, column, beam, slab, ramp, staircase, shear wall, diaphragm wall, non-structural wall, and the reinforcement quantities for the scope of work, which is the basement 1 and the ground floor. Here you can see that the major variance is in the column, beam, and slab concrete quantities, majorly because of the curved beams, slant columns, and uneven beam depths, and the reinforcement quantity is also varying by 1% as the Revit does not take into consideration the development length and lap-in length for the reinforcement part. So after calculating the manual quantities for architectural, structural, and the four services, we prepared a BOQ for the manual quantities and the automated quantities. And after comparing both of them, we got to know that As per the manual quantity takeoff, the total cost for the scope of work came out to be rupees 11 crore 35 lakhs 62,776. And whereas as per the beam model, the total cost came out to be 11 crore 19 lakhs 48,810 rupees. So this shows that the model quantities were more accurate and resulted in cost saving of rupees 16 lakhs 14,000 for just two floors, which is our scope of work, which is basement one and ground floor. And in addition to this cost saving, it also eliminates manual labor, which is a really advantageous things in today's market, today's practice. Coming on to the site layout for our project, the the site layout is shown here, and the current labor and vehicular movement is also shown in the layout. So as you can see, there are two gates on the north and the south. So there is a security cabin, shuttering yard, staff toilets, designated uh, staff toilets, QC lab with curing tank, water tank, labor toilets, designated labor toilets for female and male, labor restroom, safety room, first aid room, store room, conference room, PMC office, fire point, contractor office, steel scrap yard, steel cutting and bending area, steel yard, assembly point, safety park, staircase to access the basement where execution works are going on, labor pathway, drinking water area, curing tank, and crash. As you can see in the layout that because because of the unorganized stacking of steel in the rear part of the building, the labor movement in this part is not smooth. And and we also found the shuttering material which was not arranged properly, due to which uh, the vehicle can also not move beyond a certain point. Coming on to the plus delta analysis for our project, the pluses or the positives which we found were designated labor toilets were provided for males and as well as females. 1 meter wide labor pathway was provided. The safety billing boards were continuously updated, and there were adequate safety awareness at the site, safety awareness boards at the site, and vertigo tests were conducted for each labor at the time of interview. The the negatives or the deltas which we found for at the site where the steel was not or arranged property and also not stacked property, due to which the movement of the labors as well as the vehicles got restricted as it was not arranged properly. The vehicles were not able to move beyond a certain point, and because of this unorganized stacking of reinforcement, uh, the it was it was also not isolated or closed properly, due to which there there were chances of it being corroded. So there was only a single access point to to access the execution activities, due to which it possesses a major safety risk during emergencies. So there we also found that there were limited fire safety points at the site, and in the labor pathway which is marked with the green highlighted with the green color in the site layout, uh, we we found that there is a falling material falling hazard, as it is not, as the labor pathway is not covered uh, properly. As mentioned earlier, because of this inadequate unorganized stacking of steel, there was inefficient movement of labor and materials. And we also found that there was absence of emergency power backup at the site. So based on the observed movement of the site and to optimize the path of travels, we have proposed a site layout. So the the additions or the changes are highlighted using the red color. So first of all, the crash, which was initially just adjacent to the shuttering yard, was moved near to the labor restroom. So there was another entry access provided uh, near third entry grade provided with a security cabin. The QC lab was also moved just adjacent to the contractor's office, and another staircase was provided on the north side to increase uh, the to increase the for efficient movement of laborers from both sides, from north and south side. So these changes are shown in the proposed layout, and the staff visitor movement, the labor movement is also shown. So coming on to the crane analysis, uh, we carefully observed how the crane was used and was being and was used at the site, and we concluded that the crane 1 is not reaching the shuttering yard, and the crane 2 is not reaching the steel stacking yard. To address these shortcomings, we have also provided proposed cranes. Uh, so the crane 1 needs an increase in capacity to 10 tonnage with boom length of 50 meter, and the crane 2 needs an increase in capacity to 12 tonnage with boom length of 55 meter. These upgrades shown in the proposed crane layout, uh, which is on the right side, resolve all the limitations of the earlier crane setup. And we also have concluded that beyond the once the execution um, once the basement 1 is executed, based on the proposed cranes, only one crane, which is the crane 2, will be needed for the execution activities of the ground floor till the 31st floor. So coming on to the POT analysis, so first is the labor toilet to labor staircase. As you can see into the existing site layout, the labor had to take the south side labor staircase and go all the way around to the uh, labor toilet, the which is highlighted with the number 6. So in the proposed layout, as mentioned earlier, we brought the we we proposed an access another labor staircase on the north side, which is highlighted with number 20, and by that we we managed to reduce the travel time. So we for that we assumed the speed of the labor and calculated current the the part of travel time in the model. So the current time came out to be 93.6, and the future state time, which is the time calculated after incorporating the necessary improvements, it came out to be 15.7. The variance in that came out to be 77.9. As you can see that the change is very drastic, and similarly the most commonly uh, travel paths which were observed on the site were optimized. So here you can see the graph that shows all the travel paths, commonly used travel paths at the site, and how and after the proposed changes how they were optimized and reduced. So after applying path of travel optimization, travel time across most site routes dropped noticeably. The consistently lower future state time indicate better circulation, fewer movement delays, and overall improvement in productivity, accessibility, and workflow efficiency. And finally, coming on to the cost estimate for optimization. So for to uh, to negate the delta, which was the falling material hazard, we have provided GI roof fabrication for labor pathway, and as we had provided the additional access ladder for labor on the north side, we have calculated the cost which would be needed to install that labor on the north side, in the ladder on the north side. And as mentioned earlier, we increased the boom length of the crane in the proposed crane analysis. So we have considered the monthly tariff for that, and we have considered the period for which this crane will be used, and the the earlier uh, cranes which had the 40-meter boom length, which was provided, which was provided in the existing layout, which is used in the existence, that monthly tariff was subtracted. So the total cost for this improvements slash optimization came out to be 42 lakhs 54,000. So by investing an additional 42 lakhs 42.54 lakhs, the crane achieved the full site coverage, labor safety improved, and emergency evacuation and site accessibility became easier. The proposed site layout also saved time and boosted labor productivity by reducing waste. So coming on to the 4D simulation, the you can see the milestone schedule provided for the scope of work, which is the basement one and the ground floor. So the total duration for these works will be 138 days, and the it was it was actually going to start on 16/4/2024 and planned finish was 31/7/2025, but it actually got started on 17/10/2025. So as you can see here, the overall delay of our projects is 185 days, and because the because of heavy reinforcement and congestion at junctions, the is one of the main reasons by uh, of the delay. So uh, it is also mentioned here. See because of the heavy core wall reinforcement, there was 6 days of delays and 4 days of delay due to beam and column reinforcement congestion. So for 4D simulation, we picked up two use case analysis. For first being the reinforcement congestion at core wall and beam junction, and the second being reinforcement congestion at slant column and beam and slab congestion. So I had already mentioned in the previous slide that there was 6 days of delay because of heavy reinforcement in core walls and 4 days of delay um, due to reinforcement congestion at the junction. So so this the beam use case was visualized using Synchro 3D, and it was observed that if the execution team had visualized it beforehand, they would have they would have been better prepared to execute these activities, potentially preventing delays caused due to the reinforcement congestion. So the 4D simulation helps helps in sequencing of activities which enables the stakeholders for better visualization of these activities, and 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 they can be better prepared to execute these activities, and by this visualization uh, the delays can be mitigated, and it the 4D simulation is a valuable tool which can be used to not only visualize the activities but for the planning of for site planning and procurement of materials. So coming on to the conclusion, these are the challenges which we identified through questionnaire survey which we carried out through by taking a short survey consisting of 25 questions with our stakeholders, and we identified these to be the major challenges, the major project specific challenges, and with incorporation of the integrated construction practices, we managed to resolve these challenges, and the challenges which were highlighted uh, using the red color were specifically resolved using the 4D simulation, quantity takeoffs, and layout optimization. Thank you.